All right, y'all, we're going to go ahead and get kicked off. We'll probably have a couple people coming in. Thanks for everybody coming out here. We're excited to be presenting at Hadoop Summit this year. My name is Henry Sowell. I'm the technical director for the public sector team at Hortonworks. On stage, I've got Devin Pinkston and Ian Brooks. I promise not to mess up their names. They are solutions engineers on the public sector team. We are responsible for a wide variety of missions in the public sector, everything from federal agencies, intelligence community, Department of Defense, federal civilian agencies, to our state, local and education areas, universities, to your local police departments. So we cover a lot of different problems within the public sector community. And our job is to design technical solutions using Hadoop and Apache NiFi to enable these organizations to complete their missions. When we go in to these organizations and start laying down Hadoop, there are over 26 different components within our stack, and with that much, a lot of people can get overwhelmed, and the question is, where do you start, right? And the whole point of designing one of these architectures is really to enable the organization to extract actionable intelligence from the data that they're dealing with. So today, what we really wanted to do was do a presentation that covered a modern data architecture from data ingest all the way to presentation for our users within our organization. And to do that, we've created a notional scenario where our team is going to be acting like the San Francisco Police Department. Not officially with them, we're just using their data from opendata.gov. And so what we're doing as the police department, we're going to be covering a few different problems. One, we're collecting crime incident data for the San Francisco area. And one of our issues is, how do we ingest, store, and serve this data that we're collecting? The second is, how do we enable non-technical staff to actually gain information from this data? And then, how do we enable our data science team to be able to go in and do discovery and gain actionable intelligence from the data that we have? And so to really answer these questions, we've set up a notional team here from the San Francisco Police Department. Devin is going to be acting as our lead architect for the police department. He's responsible for data sources, ingest, designing APIs for other people to hit, and to creating applications to run on HTTP. And then we've got Devin. He's going to be our lead data scientist who is responsible for gaining that actionable intelligence and doing the discovery. So to start us off, we're gonna pass it over to Devin. Devin is going to walk you through how we really started this journey and discussing the police department's architecture.
Awesome, thank you. Thanks, Henry. So my name is Devin Pinkston. I'm a solutions engineer here at Hortonworks for the federal team. Let's see if this goes next. There we go, sweet. So what we're going to talk about here is, Henry laid out a really, high-level idea of what we're trying to do here is pulling data from the San Francisco Police Department, right, bringing that in and then serving it up, right, to analysts, chiefs, program directors, whatever it is. So what you're seeing there on the screen now is a high-level architecture of what we're trying to do. It's got a little bit of what we'd want to do too, right? So this is something that we want to keep building upon and adding in other data sets, right? So other police departments too. So to tell this story, we're actually going to start, where the data is originating from, right? So we're going to start with data ingestion, then we'll go to data at rest, where it's being stored, how it's being accessed, and then finally where it's being visualized. So it's going to be a left to right flow here. So starting with data ingestion, right? The best solution that we have is Apache NiFi, right? It's the core component, core project of Hortonworks data flow. It was open sourced out of the NSA about 3 years ago, when active development there for about a decade, right? Close to 10 years now. The reason we chose this is some of the features that we get out of the box with it, right? So we get guaranteed delivery, some back pressure support. We can do simple event processing in it, right? And a lot of other stuff, right? But one of the main reasons that we're going after this is because it's all a visual interface, right? So a lot of times we have this data ingestion problem. We're bringing in data from different sources, whether that's a REST API, flat files, logs, whatever it is. There's a lot of manual code done, right? You have someone that's doing, actual programming in building ESB pipes, or just some actual data wrangling, right? Maybe it's some Python, some bash scripting, right? You have developers coming in, going out, right? It's hard to maintain, it's hard to keep up with. You start introducing spaghetti code into it, right? It becomes a problem. So that's why we wanted to go with Apache NiFi, and we'll actually show it too, our flow for this. We'll show all the tools that we're using. So we're gonna kind of reduce that burden, right? Get rid of those hours, right? And then get those guys focused on building stuff that matters, right? Those data applications so we're driving value from our data. So after we have this data in motion problem solved, right, how we're gonna handle it, right? Where are we gonna store it? Right, so for our solution here, we chose Apache Accumulo, right? So Apache Accumulo, if you're not familiar, it's a NoSQL database. It's based off of the Google Bigtable paper, right? So just like HBase, there's a couple others out there too. Very scalable. The reasons we chose that over any other options that are out there is a few things, right? It's got cell level security baked in. So when it was originally architected, right, that was one of the core principles about it. Ingestion rate, right? It's at core ingestion rate, as far as like numbers, entries in per second, there still is nothing that's beaten that. And then there's a lot of papers out about that too. And then finally being able to scale. Right, so we were looking at something here. I mean, we probably could have gone with a bunch of other stuff just to solve our interim problem that we're trying to work with, right? But our goal is to start bringing in Dallas police and Washington, D.C., and a bunch of other cities, right? Bringing all this data in all the time and being able to scale and handle that, right, is not an easy tool, not an easy problem to solve. So we get some other stuff too that we're going to look forward to building to. So we get like some secondary indexing, some iterators, some server-side programming that we can do with Accumulo too. We're not using that yet. All right, but that's something we can look forward to building with. So now that we have this data, in motion problem solved, we're able to bring it in, we're able to store it at rest. Then we want to start working on data access, how we're serving this data up to our UIs, our data science workbooks, and stuff like that. And so what we started going after is a decentralized approach, right? And this is where we kind of came to the microservices idea and going after that. So these services that we build, whether it's a REST API, and you'll see that incident REST API there sitting on top of Accumulo. That's something we built, and we'll show that. It does one thing, and it does it really, really well, right? So the incident REST API is not going to worry about having authentication baked in with it. It's not going to have the UI too. It's not going to be this monolithic architecture, right? It's decoupled, right? So we focus on componentization and to be able to handle this, right? So the goal is to be technology agnostic, right? So working with that Accumulo API, it's a Java implementation, right? We can work with Java there. All right, and then once we start serving this data up over a RESTful interface, we can really be interoperable, right? So Ian, who's an unbelievable data scientist, right, can do some great stuff with Scala, Spark, which I can't. I'm horrible. I'm a Java, Node.js guy, halfway, right? I can start serving this up to him, and he can start working magic. Or if we have someone else come in that does Python, they can start working with it, right? We're really kind of promoting the best technology to solve the problem. And then our last piece is actually visualizing this. So you see the Angular, or the big A, that logo up there, that's for AngularJS. It's on like Angular 4 now. It came out of Google a long time ago. This is like a BYO MVC framework. I like to call it that. Bring your own model view controller framework to it, right? So if you're doing PHP, JavaScript, whatever it is, React, Vue.js, right? It's a nightmare. JavaScript's crazy, right? You can choose a tool that you're most comfortable with or what you want to work with to be able to access this data. And then we're going to also serve it up to Apache Zeppelin, and we'll show that. Before we jump into the demo, right, this was kind of our basic schema, right, or our basic idea for storing data into Accumulo, right? So you can see our rows coming in, and we'll show this. We're actually pulling in dates for rows so we can kind of bring it back, right, by time, a range of times, right? The goal is to kind of start bringing in delimiters into that, right? So we'll have that epoch time, maybe an underscore, and then a crime type, and then maybe another underscore, maybe a bounding box or some coordinates, right? So when we start bringing back data, right, to Ian's, to the Zeppelin UI, to the Angular UI, we can do a lot, some pretty cool stuff too. So we'll jump in now. Drop this thing. Where's exit show? There you go. I want that. So we'll jump into NiFi. So if you're not familiar, if you haven't seen Apache NiFi before, it's the core project of Hortonworks Dataflow. You go download this on the website. You go download from Apache or from the Hortonworks website. It's going to look the same. The only difference will be NiFi up top left there will say Hortonworks Dataflow. We've got some other stuff going on here. This is in our little engineering cloud that we have. So we've got some other flows that we're working on too. But this one, we did a really simple flow here to start bringing data in. Hopefully we can kind of see that. I know that text is small. But we'll start up there in the top left for this flow. And what that's doing, there's a web service, for almost all these police departments, and they'll have other stuff too. They'll have agricultural data. That's the whole open data gov stuff. It's really neat. And we've got a nightly cron job going. So a lot of these police departments, they'll update, they're pretty lazy. They'll do 16 days. San Francisco is 16 days. They're 16 days late, right? So I think it's right now we have May, 26th or 25th or something like that. So we've got a nightly cron job that runs. If you're not familiar with cron, that basically means that every night at midnight, we're going out, hitting that web service, and we're pulling all the data in, right, for that day. One of the awesome things about NiFi is the expression language that you can work with, right? So, what you can see there is the endpoint. I know that's really tiny. But on the left there's a base URL where that web service is located. And then we're actually taking the current date, converting that down to a number, and then we're subtracting 16 days from it, and then formatting it, to the right format that web service expects. I think it's year, month, day, DD. There you go. That's why you can see it. So when we go hit that every night at midnight, we start pulling this data back. It varies. We might get 500, might be 1,000 incidents. Really depends what's going on in San Francisco. I'm not going to jump into every single one of these processors. Each box is called a processor. But what we're really trying to do is bring that data in, split it apart. It comes in as a JSON array. We're going to really dive in, split it up into individual JSON documents, and start pulling out relevant data. And the stuff that we're really focused on right now, for this simple use case, is pulling out the date and the time. So what you can see up there, right, is we've done some JSON path manipulation in the step before that, but we've pulled out the actual date that comes in with the incident, and we pull out the time. For some reason, they don't put the time in the date. You can see that up there. There's seconds, minutes. For some reason, they just leave that blank. It's zeros. So we kind of concatenate those. We bring them together, push them down to a number, and that's how we start ingesting data. And that's how we're able to set those rows, put a scanner on a range of rows in a cumulo when we start bringing it back to our Angular UI and to the Zeppelin work that we're doing too. And the last step's pretty self-explanatory down there, the put a cumulo JSON. So we've got it in a JSON format. We kind of specify, you saw the schema, we specify the column family, but then the column qualifier and the values, we're just mapping those in as key value kind of, dumping them into a cumulo, and then we start bringing data back. So now that we've got this going in, we've seen the cumulo schema. We don't really need to dive in there. That Angular UI that we built up is pulling from a REST service that we have out in our little field cloud. So I'm VPN'd in here and SSH into our little field cloud. And I've got a little CentOS box running. And I Dockerized our REST API that we built, and I'll show that actually. I don't know if anyone wants to look at code, but can I zoom in on that? Nope. But it's really simple, right? I'm using Spark Java. It's not Apache Spark. It's called Spark Java. It's a REST API framework that you can build really quick, REST endpoints in Java. We're going in, connecting to a cumulo, and we're building incidents. We're pulling back some of the relevant stuff, right? So we've kind of decoupled that rigid structure that it was coming into, pushing it into columns, and pulling back the data that we need. So for the Angular UI, we're only going to pull back, a few visualizations just to prove a point, and then we'll show how we're reusing that in Apache Zeppelin as well. And we've Dockerized it, right? So we've got this container. Anyone that's familiar with Docker, you can see the container actually running out there. It's been running for 32 hours now. And we can do a little curl on it, right? A little get. And you can see some of the data that we're pulling back. We've got close to a year of data in there. There's a fair amount of entries. It's very performant to pull this data back. Schema's fast. But you can see we've got, I know that text is really small. It says crimes by category. We've got some entries there. And then we also have crimes by date. That's a typo. It should say crimes by day. That's my fault. And we're bringing that back to the Angular UI. This could be Vue, whatever you're doing, at your current setup. But what you're seeing now is an MIT licensed Angular, admin template I found on GitHub. There's thousands of these out there. I just pulled it down, added some chart.js dependencies to it, and I started pulling this data back. So that REST API, that result you just saw coming back in that command prompt is what's being visualized here. I'm not doing anything else. I'm literally just sending it right to that chart.js framework. And this is kind of playing off of that use case. The second use case that Henry was talking about, right, is a non-technical audience, being able to derive value from this data. Right, so maybe this is a police chief in a different precinct, right? And maybe he's looking at, hey, right now, this URL that we're hitting inside of Angular is only pulling back a week of data, from our cumulo database, right? And we see that larceny is crazy, right? So in a week, we've got, close to, 1,200 counts of larceny in San Francisco. And I heard the OS there, right? Yeah, Ian's going to show some really cool stuff. But there's a lot of other stuff that we can dive into as well. So on down at, if we start going to like use case 3, which Henry was talking about too, we can start really, looking at, some really in-depth data science workloads and how we can offer that up to the same REST APIs that we were building. And that's where Ian's going to take over.
Thank you, Devin. I'm Ian Brooks. I am also a solution engineer with public sector, work under Henry, teammate with Devin here. So before we start here, introduce to you Zeppelin. So Apache Zeppelin is a data discovery tool. It's a notebook. So it's not a full-fledged BI tool, but you can sort of do things like that. One thing that makes it really nice, though, it's very shareable. So I can create this notebook and I can actually hand it off to somebody else. So let's go through the load here. Using Spark, as you can see, on 1.6, so nothing crazy there. I'm taking the REST API link that Devin has set up for me. And from there, I'm going to build a Spark data frame. I won't go too much detail about a Spark data frame, but a data frame is a table where different columns can have different schema associated them. And then there's additional libraries within Spark to manage that data as well. So I grab the URL, I create an RDD, redundant data set in Spark, and then I create a data frame. And what I'm going to do first is you're going to see a little bit of the information that's coming out, and then I'm going to print the schema. So I want to just get an idea of what I'm working with. So initially, everything's string, if you guys can see that. Yeah, way down here. Oh yeah. Green one. So if you see right here, everything in that data frame is a string. And that's fine for some use cases, but in this case, we've got geospatial data, we've got latitude, latitude, we've got a time, we've got a date. We really want to get that into a correct schema. So that's what I will do next. So one of the nice things about Spark and data frames is that you can do really quick casting. So let's see. What I'm doing here is with that with column, I'm adding to that data frame, but I'm casting that date value instead of a string into an actual date. So that's actually a date variable, something you would see akin to in most databases. And then I replicate that for hour, turning that to a number or a timestamp, and then latitude, latitude for doubles. And I pick doubles because we've got a fair amount of precision here. We're dealing with neighborhood data, so you really want to get as much precision as you can keep. And the last step here is I'm just building another data frame that I'm calling feature data frame with all the features that I'm looking for with the correct schema. And then finally, I will actually print the schema out here so you can see that, in fact, date is now a date, and latitude, latitude are now doubles. And one step I do here to actually do Spark SQL is I register this data frame as a Hive table. So it's a temporary table, which is really, really nice tool. As you can see right here, I'll then just bring up the table. So why I bring this up is, one, I want to verify the data is correct. I want to verify it's complete. I actually want to see it. And so at this point, this is just another table I can throw SQL at it. And that's exactly what we're about to do. So the first question I ask, okay, so what about crime events by precinct? Let's just get an idea what's out there. So you've got, let's see, Southern, Northern, and Mission here are the pretty big things. The questions I'd ask here are, what's the landmass? What's the population here? Let's try to get an idea of what does that really mean. So I can't read too much into that initially. The next question I ask, okay, what about day of the week? So this is what I refer to as the beach ball graphic. Pretty evenly distribution. It's not perfect, but it basically tells me that criminals don't take a day off. They're just pretty clear right there. They pretty much every day of the week they're going for it. What about time of day? Well, I think, most of us would say most of the crime's going to happen maybe when the bars close or, late at night people have got a little alcohol in them. It's not quite the case here. You're actually seeing at 5 p.m., 1700, at 5 p.m., that's actually when you have the highest crime rate. And then criminals, they do sleep. Happens to be at 5 in the morning, but they do take a little time off there. Okay, what about by date? Now, we mentioned we've got about 4 months of data I've just pulled in here. It's not perfect distribution. It's pretty close, though. Nothing really points out here. The one question I would have is, why less on this date? Maybe it rained, something like that. So we'd actually have to bring in more weather data to really look at that a little closer. But nothing really sits out here for me. So let's keep going down here. What about crimes by category? Something Devin alluded to. Fair amount of different crimes. Pretty diverse here on this side of the chart, as you can see. But there's a nice big piece of the pie here. What is that? Larceny, theft. And this is going to continue this trend here. So this is just the number of events by category. Well, the next question I ask, what about resolution? So what happens to these events? Because that's part of the data field, part of the table. Well, as you see, most of them, the Pac-Man chart here, are unresolved. Pretty frightening, actually. Almost 75% are not resolved, and then you've got almost 24% that are arrested booked. So the question I have, okay, what kind of crimes are not getting resolved, and what kind of crimes are getting resolved? So once again, larceny, theft is a larger piece of the pie, and that doesn't shock me. Well, what this one did though, assault. 8% of assault is unsolved. That's pretty outstanding, I think. It's pretty high. So what about on the arrested side? Well, larceny, theft, once again, other offenses on this one. And Henry made a good point. This is probably ticketing. There's probably a reason why you actually got a resolution here. With something we'd have to ask more questions about. And this is assault. So you are seeing a good chunk of assault actually getting resolved, which is important. Let's continue down here. So I wanted to continue the analysis. I wanted to try to get an idea where these crimes were happening around the city. And right there, I don't think it takes a genius or a data scientist or anyone to say, hey, there's something going on with that. What is this? So this is the 800th block of Bryant Street, which is not terribly far from AT&T Stadium in San Francisco. So let's look more in detail at what we have here. All right. So one thing I've added in, Bryant Street is, yeah, it's about here. Right there. Let's see the marker. It's kind of almost there. One thing you notice is, well, I have this nice chart. The red dots are unresolved crimes. The blue dots are resolved. And you can scale back and get an idea where it is. You can also get an idea of what is the right and the left of the city. So you do get a concentration here, clearly. And I would start to ask questions, why? Why is that concentration there? Is it population? Whatever the case might be. Well, let's continue here with the analysis. Back on 800 block. Sorry. There we go. So once again, it shouldn't shock you. The largest piece of the pie is larceny, theft, but that's actually a larger percentage by proportion that we saw across the city. So that tells me that this street has a little bit higher rate of a car getting broken into is what I thought. And I said, okay, what time of day? When are these events happening? So I got the pinwheel graph over here. So this is 9 o'clock in the morning, and this is 5 o'clock in the afternoon. So more than half of the crime is happening during daytime when people are actually at work, which I didn't expect. That actually was something that I did not expect. It's pretty interesting. So let's look at daytime crime on the 800 block, Bryant Street. Larceny, theft, once again, an even larger percentage of the pie than we saw in the city. Let's see, what's this guy? Non-criminal, other offenses, right? Warrants. And then out of that, what's not getting resolved on this street? So you have, once again, you have a very large pie here, a very large piece of the pie for larceny, theft. So I can take big data of the city, and I can distill it down to a single block view in San Francisco, and I can come back with actual intelligence, and I can hand off to the policy decision makers and say, hey, there's something going on here with the 800 Bryant Street. But I don't make any decisions, so I have to policy.
Yeah. So what were some of the goals when we started this process, right? What we wanted to determine is that, one, we wanted to show an architecture that from data collection and ingestion out to presentation, that we could start solving criminal problems, that we could give an application that Devin created to a policymaker like myself that I shouldn't be touching the tech, but I could go through and see that, hey, crime's up in this area. It's like you would have for a BI tool or some other application in your own organization. And then I want to have my data scientists go off and actually be discovering things that we weren't aware of and patterns that we need to look at. So as somebody that was in policy in the organization, I might take this and say, hey, we've got to put focus on the 800 Bryant Street. Maybe we do increased patrolling. Maybe we do community outreach. Maybe we go in and we start working with the city council to say that there's an issue here that's broader than just a crime problem that we need to start addressing. But these are the types of things that we want to start looking at in an organization, and that having a full life cycle where it actually starts allowing us to be able to address these kinds of questions. So right now, that is our presentation. We're going to open it up to questions. I'd like to invite anybody that's actually interested in seeing public sector and some of these organizations that are actually trying to solve these mission problems. This is something that we work with every day. There's going to be a breakfast tomorrow morning at 7:30 on the second floor of Marriott. Please come out. We'd love you to actually get to see some of these public sector people that are solving these things. So outside of that, open up to any questions that anyone might have. Sure.
One guy leave.
Are the links available to take a look at?
So we'll get it posted up on the Summit site. We'll get a GitHub link. And there's a lot of cool things about with Zeppelin here too. Is that one of the shareable pieces is that as an organization, a team of data scientists could work on this, right? And that if they were to share it with a policymaker, that policymaker can also go in and manipulate some of these graphs, so that they could view it and visualize it in their own ways as well. All right, please.
In the architecture that you showed, like the NiFi and Kafka, like why you use it?
Yep. So one of the things that we wanted to do is to create a flexible architecture. Oh yeah. So the question was that in the architecture we had NiFi and Kafka, and why is that a part of the architecture? One, we wanted to be able to take in different data sources, right? So it was just a part of the design choice. In this case, it wasn't necessary for us to have Kafka, but what we're planning to expand on and some of the data sources that we're going to take in, it would be more appropriate for us to use NiFi in combination with Kafka or Kafka by itself. Yep. So in this case, as you saw with NiFi, right? NiFi was ingesting every 16 hours, but that was just because that's what that data source and the way it was currently configured, the way it was set up. But we could obviously have this being a real-time streaming portion. So whether the police department was having collection from the vehicles in the officer's car, and it was actually taking real-time events and streaming it into this architecture, we have it flexible enough that we could take in those types of events. Yep. Any other piece?
Just a little bit of detail on the REST API. Was that just a handwritten thing, or did you use some sort of visual type of tool to lay that out?
Yeah, it was all done through hand code. So real simple. The goal is to obviously expand upon that and go to like a batch scanner or something like that. But right now it's just a scanner, pulling back based on we have in that Spark. Can I go back to that? In the Spark, I'll put this up on GitHub. The Accumulo processor is up there. It's not complete, but it works. But this is all hand done. This is what's running out there on that little VM that we have, that CentOS VM in our field cloud. But we're bringing in two parameters, a start time and an end time. And based on that, that's what we said is the row to bring back in the scanner, right? And inside of that, for the different kinds of APIs, right? So some of the stuff that we're doing in Zeppelin, and then there was one other one we had for the Angular UI. We bring back a little bit of a different kind of formatted data. So, but it was all done with Spark Java. It's simple, light.
Yep, and he referenced it a little bit, but on the NiFi flow that you saw, out of the box, you get something like 200 plus processors. Well, there isn't an Accumulo processor, right? So for this piece, Devin actually wrote the processor that's on that graph. So they really, when you talk about the flexibility of the platform, that if you have a particular source or destination, or you want to do some sort of transformation that is particular to your organization, it's just Java, right? It's something that you can develop in-house and deploy, like Devin deployed for the put Accumulo JSON processor.
Henry's saying I'm not a good Java developer. That's basically what he's saying. Anyone can do it.
One other question is more philosophical, I guess. When you're dealing with the public sector, do you find that you're going into places that have big selling them on the idea of implementing data.
Okay, so if anybody didn't hear, philosophical question of when we're going into the public sector customers, do they have big data, or are we having to walk them through how they might actually have a big data problem? Does that characterize it? Okay, so we actually have both, right? And I'll describe why, right? So we'll go into, say, a federal agency. That federal agency, they know they have a big data problem, right? They have multiple petabytes of data. They have they have a mission, say a counterterrorism mission, right? Where they know they need access to the data, they know how important it is, and they know they need assistance in making that happen. So we don't have to go in and convince them on that. Some of the things that we help uncover in certain organizations are folks that have traditionally just thought in a siloed manner, right? So it's a state agency that our job is to run and create this single report for this single data set, and that's our job. And what we can come in and discuss with them is really just trying to think of the problem set that you've got and think of it outside of the bounds of your current questions, right? So that happens on a frequent basis. We had, we went into an organization and they were more concerned about how fast they could get Word file attachments from their email than they were addressing their actual mission concern, right? So we were able to come in and said, from this crime problem, we know that's your mission. How are you able to do that? And they talk about, we've got these 30 analysts that look at, various different data sets. And within an hour, we were able to design an architecture where 90% of that can actually be achieved automatically within HTTP, right? And solved in this type of platform, and freed up their analysts to do actual real good things that humans are able to do. And so we have both sides of it. Yeah, and just like this question, right? We're the public sector team, so we can take questions on public sector missions or this architecture as well. So anything else? All right.
Your slide had references to like solar and Druid, but you didn't really talk about it much. Can you elaborate on where you might use that in a use case?
Yeah. So I'll take first stab, and then you take
Defer.
second. Yeah. All right. First stab, right? So like solar, it's a great search index. So there are certain use cases where take a non-technical user, right? Everybody knows how to run Google, right? Google this, right? It's just a part of our vernacular. So the standard intelligence analyst that's working in a state bureau of investigation, they know how to run a Google search, right? So you can enable an application to have a solar index that might be able to take this data in, and that user could say search for a type of crime or search for a particular user. They can run those things. So that architecture allows for that type of flexibility. And so it's just part of that architecture. So this is one for our team. It's just kind of a start and where we're building out from. And again, very similar to the Kafka decision. It's a decision for flexibility so that we can operate more use cases. And then Druid.
Yeah, sure. I think that's another one where we want to bring it in to be able to do, maybe we package it with something like CalSci, right? And we're able to do some streaming SQL data that's coming in, or do some OLAP, right, on data that's coming in. So if you're not familiar, Druid is new to the Hortonworks data platform. So on that, I think it looked like asparagus. I think it was like the first slide or the second slide, right? That just came in with HTTP 2.6, right? So that's a new addition. Really cool data source to kind of enable you to do some different analytics. There's also a UI package with it called Superset, which is open sourced out of Airbnb. So you can actually, out of the box, right, as soon as you start deploying HTTP 2.6, maybe you start getting some streaming data, or you just offload some CSV, JSON data, whatever it is, into Druid, you're able to start exposing that, through a UI right away too, which is pretty neat. So something to look at if you haven't heard about it yet.
Yeah. There was a question in the back.
So you mentioned that the NiFi came out of the intelligence community. I think same as well.
Yep.
I mean, does Hortonworks advocate and work with public sector to try and get more of that technology out of the intelligence community or out of the DoD and into open source?
Yes, yeah. So we work on a variety of different initiatives to help with that. One, we were part of the White House initiative to work on openness within the government space to help, show an example of how we're doing that in the open source community already, but then helping them through their process. So on the public sector side, we definitely provide consulting advice into how does an organization move into the open source community. We're actively working that with some of those same places where NiFi and Accumulo came out of to help continue that endeavor. All right. Anything else?
So what part of the stack allowed you to run SQL queries on data? Was that Accumulo?
All right.
Oh, so what I had to do is using the API he gave me, I built a data frame from that, and then I could run Spark SQL on top of that data frame. Right, and that's why I had to do some of the schema there as well. Because the next steps I would do could be geospatial analysis, or I could actually do some real machine learning, something like that. It's really a starting point for me, is what that is, what you've seen.
Yeah, one of the cool things that, what we want to do further in this notebook, right, is you saw the geo of the crime incidents, right? But what if we were able to start taking in other data points, like give me points on a map for all alcohol serving locations, and give me a heat map underneath that of the crime incidents, right? So if we can see hot pockets around, and not the food, but hot pockets around the alcohol locations, that might affect our policy, right, in our organization. So there's a lot more from a data science perspective that we can start doing. And as you create more and more features, we can actually go in and do machine learning to start helping to identify particular problem areas or things of focus for a police department that they need to start acting on. And one of the things that it also kind of I'd like to answer a question that you didn't ask. Can Spark against Accumulo, right? So there are connectors for doing that, and so we have public sector customers that are doing incredibly innovative things with Accumulo in combination with Spark. And so they have the scalability and cell level security and the ingest speed that Accumulo offers you, and then some of the fantastic tools and interface that you get with when it comes to Spark. Okay. Any other last pieces? All right. Thanks everybody. We really appreciate it. We're going to be walking around. We appreciate everybody's time. Thanks.